Now we're going to take a look at nonlinear systems of equations. Systems of equations really deal with grouping multiple equations together and solving them simultaneously, essentially finding the intersection points of the graphs. When we dealt with linear systems deal with intersecting lines or planes or equations basically that are first degree polynomials. Now we're going to look at nonlinear systems, things that have larger degree polynomials. They could be quadratic in nature. They could be a larger degree than that. They could have multiple variables involved. You could be looking at ellipses or circles or hyperbolas, different conic sections. You could even look at logarithms and exponential equations and trying to solve them simultaneously. So we're trying to find the intersection points. Now for our discussion, I'm going to stay mostly with polynomials. I'm not going to get into the logarithms and exponentials, but the polynomials could include polynomials of two variables. So we might see some ellipses and hyperbolas, the conic sections thrown in there as well. Okay. Now, before we start, there's really some key points that I want to point out. The first thing is that, again, in solving these systems, you're finding the intersection of graphs. Okay, so that's a big one. Finding the intersections of graphs. Okay, but now we might be finding the intersection of, say, a parabola with a hyperbola. Okay, or it could be, like you might be finding a parabola that opens this way and a hyperbola, that might go something like this. And so you might end up with something like 4 intersection points or something. So just to give you an idea of the types of things we'll be looking at. But again, there's still intersection points. So the solutions to the system will be all points that satisfy all the equations in the system, namely the intersection points. That's where they all cross. Okay. So that's going to be important. Another thing that's going to be important is that you can sometimes use your calculators to find, or some sort of graphing utility to find the intersection points. Okay. We're not going to do much with that, but sometimes it's nice just to, because I really want you to learn how to do this by hand and kind of get some techniques, some mathematical thinking involved. But sometimes it's nice just to plot the graphs and see, you can visually see how many times they intersect so that you kind of know what solutions to expect, okay, or at least what are reasonable solutions for that problem. Maybe they intersect 4 times like this, but you end up solving it and you only get 2 answers. You know you probably did something wrong. Or you know that one of the solutions, the solution, there should be 1 in each quadrant, but you end up with all of them in the first quadrant. You know you did something wrong. So, so there's different variations there, but at least to get some reasonable idea of what the answers should be. Okay, use a graphing utility. Okay, your book will call it a utility, just for general terms, but a graph calculator, computer, or something. Use a graphing utility to check reasonableness. Is it E-N-E-S-S? I don't know. I'm not even sure I spelled that right, but reasonableness. Is it even a word? I don't know. Reasonableness of answers or of solution set. And our solution set will be XY ordered pairs again. So that's the first, or that's the second thing. Then we're primarily going to be using both the substitution and the addition methods here. So we could use, and really a combination of substitution and addition, or some would also call that elimination. Okay, so those methods can be used. and are really going to need to be used. And sometimes you'll use both in the same problem. It really takes some creativity to solve these. Another thing that I wanted to point out is that sometimes in solving nonlinear systems, you may end up with some extraneous solutions. So extraneous solutions are possible. Remember, extraneous solutions are just, you get to the end, you get an answer, and it actually doesn't work in the original problem. That is a possibility with nonlinear systems. And so, as a result, you really need to check your answers. Okay, you check them before you put them in a solution set, because you may get, say you end up with 4 answers and only 2 of them are actually solutions. The other 2 you have to discard. The 2 that are solutions would have to go into the solution set, and the other 2 stay out. Okay, so you want to be careful of those extraneous solutions popping up. It's not very often, but it does occur at times. Okay, and then I think, if I'm remembering correctly, the last thing I really want to mention is that you really have to be creative. Okay, there isn't a set method for solving nonlinear systems. No set method. Be creative. That's the best advice I can give. I'm going to show you a few examples. It is by no means all inclusive of every type of example you'll see. And so even the strategy involved in solving these varies from one example to the next. And I can only give you some clues as to things you can look for, different patterns and ways to eliminate variables that might help you narrow down your solutions. But like I said, it's not fully inclusive. It doesn't exhaust all the possible strategies and methods that you could use to solve a nonlinear system, especially because we're really just going to deal with polynomials in this, polynomials and conic sections with these. So just be aware of that. If you're looking for a cookie cutter recipe to solve these, there really isn't one. You just have to be comfortable enough with the mathematics and sort of creative enough with working with the variables and combining things to where you can eliminate variables. But the main strategy is, if you can eliminate a variable, you can usually solve for what's left. And since our systems are primarily going to be 2 variable, an x and a y, then we're really trying to eliminate one variable and solve for the other one. All right, and again, it's going to take some creativity to work through those. So we'll look at a couple examples coming up in the next few videos, and hopefully give you enough ammunition to be able to tackle the homework and ultimately the tests.